Hi everyone. Good afternoon, guys. Good afternoon, right? Very good afternoon. How are you all? Everyone, how are you? Hope you're all doing well. Right. So we'll be continuing our discussions on this highway quick revision, you can say, right? What is that we have discussed? Some parts we have discussed, you can say, and we'll be continuing our discussions on this traffic engineering only, right? As now, so that traffic engineering parts only we were discussing now, as no, that a PHF gets over and some other parts also over, you can say, right? And we'll be continuing our discussions on this, you can say, right? So this highway quick revision series, will be having now. All of you, welcome to Unacademy. Let's crack it, right? Everyone get ready to crack, all of you. So audio video both are clear, all of you, everyone. Yeah, somebody. Pavan, Manvendra Singh, hi, good afternoon. Lunch gets over, all of you? Your lunch gets over or not? Right. So these are all GATE 2024 toppers from Unacademy. Those who have secured AIR 1 from various branches of engineering, you can say. And this mega offer, right? So this mega offer is extended up to 4th August, all of you, right? This mega offer is extended up to 4th August, right? What is the offer? Anyone having idea? That GATE subscription now at which one? At 8,499 rupees only, right? What is that a referral code you have to use? You can say RP Civil is the code you have to use, right? And now this is if you are taking plus subscription na 6 months subscription, if you are taking that 2 months extra you will be getting, and that is at 8,499. and if you are willing to take iconic subscription 6 months, if you are taking there also 2 months free you are getting, that is at 14,999 rupees, you can say, right? Yes, Pranav, transportation again will be covered, there is no doubt in that, right? So 2 more times transportation will come, right? Yes, na? One full length course will come and one crash course will come, right? Don't worry, right? So transportation and surveying will be covering it 3 times in a year, right? Surveying at least 2 times will cover, but transportation will be covering, highway especially will be covering for 3 times in a year, right? One time is completed now. After now at present we are doing the strength of materials. Once the strength of materials gets over now, we'll be going for which one? These other structural subjects, right? Like which one? Either structural analysis, RCC, steel. So after these 3 subjects are over now, so no, after those 3 subjects are over, right, again we will be starting that highway full length course in the plus course, right? Again survey will come, so highway quick revision will come, right? Don't worry, no need to worry about it. Now these are the latest batches started for this 2025 aspirants, right? On 31st July it was started. RCC by Jaspal sir, it was started at 8:55 am. And what is that a referral code you have to use? Tell me. RP Civil is the code you have to use, right? Shikhar batch, right? This is Shikhar batch. Those who are aiming for 2026 aspirants, it is on 31st July it is started. Same RCC by Jaspal sir only at 8:55 am it was started, you can say. And what is that a referral code you have to use? RP Civil is the code you have to use, you can see if you just subscribe. Yes, now coming to this, those who are taking iconic subscription will be getting these books delivered to your home within 15 days of your what subscription, right? Whenever you are taking this 15 days of your subscription, then you will be getting which one? These printed books, right? This is the list of printed books you will be getting to your home delivered within 15 days, right? Now this is my profile, you can follow me at which, and this is a referral code you recommend to all your friends, juniors and everybody, and use this, right? Now in this highway quick revision, right, how many sessions we have got completed? If you just remember the last session, do you remember, all of you? So 30 sessions we have completed, na? Yes or no? 30 sessions almost we have completed, and we'll be going for which one? This is 31st session, right? So in the 30th session, right, what is it discussed? If you just remember, everyone. So this highway quick revision, that DDHV, right, PHF we have seen, PHF completely discussed, and this Poisson's negative effect we have seen as 323 point we have discussed, you can say as na. Now today this 31st lecture, 2 more lectures will be there, 2 or 3 more lectures I have planned, actually 2 more lectures mostly. When you will be finding on 4th, right, again on 8th mostly you will be finding 2 more lectures will be finding. With those 2 more lectures, this entire highway engineering will get over, right? After that I will be starting the quick revision of this strength of materials, you can say, right? So here we will try to see rotary, DDHV and this PCUs, you can say, right? Now 323 points are gets over now. 324th point, right? So what is this 324th point? You can see if you just observe. What is that 324th point, you can say? What is that 324th point if you just observe, right? That 324th point we have to see is which one? Tell me, all of you. That 324th point we will see is what? Everyone, rotary related thing, right? Yes, na? So whenever it is a rotary, right, what is that rotary? Rotary shall, okay, rotary will go for this if you just observe. Now whenever it is a rotary, so various aspects of this rotary are important or not, right? Just like that, can we decide the rotary? No. So we have to go with which one? These various aspects, right? So do you remember how the rotary will be there if you just observe? One second. This is how we'll be having the rotary now. That road intersection if you just observe, right? So road intersection at this place, that rotary, that central portion is called as your rotary na. Have you seen this kind of arrangement, everyone, all of you, anywhere? Have you seen this kind of arrangement anywhere on the road if you just observe? Have you seen, all of you, or not seen? So that is, the central portion is your rotary, and what is that you can have if you just observe? This is your channelizing island na, with respect to these entry leaks, right? Yes, rotary, or you can also call it as which one? This is a roundabout, okay? Rotary or this is a roundabout, you can see if you just observe, right? Is now what is this one? This is your channelizing island na? So this channelizing island will be present only on one side, or it will be present on all sides, you can see if you just observe. It is present on all the legs na. It is present on which one? This all the legs, you can see if you just observe, right? Is na? It is present on which one? This all the legs if you just observe, right? So this is how you are having, right? Let us take this as a leg 1, let us take this as a leg 2, and let us take this as a leg 3, and let us take this as which one? This is leg 4, you can see if you just observe, right? Is na? So these are your channelizing islands, right? So this triangle shape wala will be called as which one? Channelizing islands, right? So as the name suggests, right, what they will be doing, tell me? They will be channelizing the traffic na. They will be allowing the entry traffic in a entry manner, right? Exit traffic in a exit manner they will be allowing, right? They will not be mixing them both, right? As na. So here what happens, you can say vehicles will be after this, right? What is that you are having? Tell me. That a median can be present here now after this, right? After this, right, which one can be present? You can say that a median can be present if you just observe, right? Median, or you can also carry it with which name? Divider na. Is that no? Median, or you can also carry it as which one? This is a divider or not? Yes or no? So now if you just observe it, what is that you can say? So here vehicles will be entering na. Yes or no? Here vehicles will be entering like this. Yes or no? Now if you just consider, right, so they may be entering like this. Some entered vehicles, as it is they are taking this left turn na. Some entered vehicles, right, as it is they are taking left turn or not? Some vehicles, there is a possibility or not? Yes or no? There is a possibility if you just observe, right? Isn't it? There is a possibility, you can say, right? Isn't it? Right. So whenever they are moving like this, right, there must be some width you should have na. There must be which one you can say? There must be which one you can say? There must be some width for this entry of these vehicles na. So without the entry width, how they can enter into this? You can say they cannot enter na. Yes or no? They have to enter only from which one? This entry width, right? Is na? Yes, we have to provide some width at this place, right? What is that width we have to provide if you just observe, right? So this is the width we are providing at this place. That width will be your, which one, this entry width E1, right? Now from here, right, what happens, you can say, from this rotary that vehicles are leaving, na? Vehicles are leaving through this rotary or not, at this place or not, for this entry leg. So now what is this width you have taken? If you just observe, this width will be taken as your exit width, right? Understood now? So for every leg, left side it is your entry and right side it will be which one, this exit, na? Left side it will be entry and this right side it will be exit or not, right? Left side it will be entry and right side it will be exit, you can say, right? So E1 is your entry width of this rotary and E2 will be which one, you can say, that is your E1 is your entry width of this rotary. Through this width vehicles are entering into the rotary part, and E2 will be the exit width of this rotary, you can say, right? Like that, isn't it? Now here if you just observe it, whenever you are entering, so what happens, you can say, there is some entry curve you are having, no? Here they will be entering in the curved manner or they will be entering in a straight manner, you can say. They will be entering in which manner? If you just observe, they will be entering in the curved manner only, no? Whenever they are entering in the curved manner, right, what is the, you can say, if you just observe, curved manner they are entering means that there must be some radius we should have, definitely, na? Without radius, right, can they be able to enter into this manner? Can they be able to enter into this rotary? No, na? Yes or no? So they have to enter into the rotary means, right, how they must have to enter? Definitely they must have to enter in the curved manner only, definitely, right? If they are supposed to be entering into the curved manner, so there must be some radius for this, na? There must be some radius we should have for this, definitely or not, right? There must be some radius for this we should have, definitely, you can say, right? Is not, how can you have this radius? Tell me. That a radius is called with which name, you can say? That a radius is called as your entry radius, now. And whenever they are exiting, so there must be some radius we should have. So what is that, you can say? That is your exit radius, now. And so here this is your central island, some vehicles, right? So these are your entry and these exit points, if you just observe, right? So this is a free turn they are taking, na? This is the portion for this free turning of these vehicles, and some vehicles will be moving around this, definitely or not? Yes or no? Some vehicles will be moving around this, definitely or not, right? Around this rotary some vehicles will be moving, definitely, right? So whenever some vehicles are moving around the rotary, right, what happens, you can say, if you just observe, whenever some vehicles are moving around the rotary, so what happens, tell me? There must be some amount of width available for these vehicles to move around the rotary, na? Definitely, yes or no? So these left turning vehicles have to take this free left, you can say, if you just observe, they have to enter, and some vehicles have to rotate around the rotary, definitely, na? Yes or no? Only one criteria we should allow or both the criteria we should allow, tell me? Only one criteria we should allow or both the criteria we should allow, tell me? Both the criteria we should allow, na? Right, what are these both the criteria we should allow, tell me, if you just observe? Both the criteria we should allow means, right, what is it, you can say? So free turning, right, free left turning vehicles should be allowed to take the free left, and these rotating vehicles should be capable of rotating around the rotary, right? So both activities must be allowed or not, right? Both activities must be allowed, definitely, right? So if you are not allowing any one of them, is there any use of this rotary, tell me? There is no use of this rotary if any one of them is not allowed, na? So it is better we have to allow both, or it is better we have to allow only one? It is better we have to allow both, or it is better we have to allow only one activity, right? It is better we have to allow which one? This both the activities, if you just observe, right? Isn't it? Now so here what is this radius they are having, you can say? That is your radius of this central island. You can also call it as which one? This radius of this rotary, na? R. So radius of this rotary or this radius of this central island, you can say, if you just, right? Isn't it? Is it clear now? Right? Now so what are the other parameters we'll be having, if you just observe? What are the other parameters you can have in this if you just say? Anyone? What are the other parameters you can have if you just observe it? There will be some other parameters also, right? What is that if you just observe? There will be width of this rotary roadway. Na? So, no, what is that width of this rotary roadway? You can say here, this is the entire width available for this rotary roadways. Na? This is your entire W. Everywhere this much amount of this W must be available. Na? Everywhere this much amount of this W must be available, you can say, right? Here if you just observe, right, what is this? You can say this is your average of this entry width and exit width, right? This is your E1, this is your which one you can say, that is your E2, and it is your which one you can say, that is your exit width E2. No? This is your entry width E1 and this is your exit width E2, right? So whenever vehicles are entering from here, they will be traveling along this and they will be exiting this one, no? Exiting this way or not. So those who are taking the free left from this leg 3 to which one, this leg 4, right? So for these vehicles to have the free left conditions, we have to provide how much minimum width, that E is the minimum width we have to provide now. Next, for the vehicles to rotate around this rotary freely, we have to provide some width. Na? How much we have to provide that? 3.5 meters we have to provide, you can say, right? 3.5 meter we have to provide, right? So what is that total width we have to provide? Tell me. That E plus 3.5. What is that E? How can you get that? Average of this E1 and this E2 will be taken as your E. Okay? Average of which one? That E1 and this E2 will be taken as which one? This E. You can say if you just observe, right? Yes, now, isn't it? Understood now, everyone? Clear? So anything else you are having? So that W will be the radius at entry, radius at exit. For every leg also, if you just observe, this is the left side, right? What is it? You can say this is left side radius at this entry only, na? So this one, what is it? You can say that is your radius at this exit only, na? If you just observe. Here also, for this also, right? What is it? You can say this is your radius of this exit, na? Exit radius. And what is this one? You can say that is your entry radius or not? That is your entry radius, right? So this is your which one you can say, that is your exit radius, and again what is this radius? You consider this is your entry radius, right? So is that clear? And what is this width? You can say this is your, what is the width? Tell me. Entry width E1, and what is this width? You consider this is your exit width E2. If you just observe, right? So is that clear? These parameters, all of you, the geometric parameters which are present in the rotary, are this clear? Is that clear, everyone, all of you? Right. Now, here the distance between, right? So this is your which one you consider? This is your entry point, na? Yes or no? From this entry point to this immediate exit point, right? What is that? You can say this is called as your length of this weaving section. That is L. Okay. Here also, our distance between the adjacent channelizing islands is also called as your which one? Length of this weaving section, you can say, right? Here this is your entry point है ना हमारा, ये हमारा entry point है ना, ऐसा ना, ये हमारा exit point है, right? So entry point से लेकर exit point तक कितना distance होगा? That distance will be your which one? Length of weaving section, you can say if you just write, is not that portion will be called as your which one? Length of this weaving section, right? So all these geometric parameters are covered here, you can say if you just write, is not? So once this is noted, tell me, I'll try to move on to this next and I'll show what are all these parameters if you just observe. Note this and tell me, everyone. Somebody tell me, noted? Once noted, tell me, I'll just move on to the next then. Noted, Pavan? or noting? Hello, somebody respond. Noted or not? Nobody is there in the class? Everybody left? Someone respond? Okay, I'll just move forward then. That is your 324th point na. Next 325th point you can say, if you just upgrade, what is that 325th point? You can say capacity of this rotary roadway. So whenever we are providing this rotary, right, there must be some capacity it should be having, na? Yes or no? It should allow some number of vehicles to flow through it, na? Yes or no? Capacity of which one? This is a rotary roadway, if you just observe. So what is the symbol we are giving for this capacity of this rotary roadway? That a Q suffix R is the symbol we are giving, you can say, right? So anybody can guess what is the capacity expression? That a QR will be equal to, it is an empirical formula, you can say, that a 280 into that W into what is it, you can say, 1 plus E by W. See your which one? 1 plus E by W, right? That is your 1 plus E by W into 1 minus, what is it, you can say, 1 minus P by 3 divided by how much, you can say, divided by how much? That is your 1 plus W by this L. Okay, so this is your capacity of this rotary roadway, right? This many number of vehicles, right? So the capacity units must be in which one? Either it is in terms of this vehicles per hour, or it is in terms of which one? This is PCU per hour, right? This many number of PCUs it will allow, or that many number of vehicles it can allow, right? How can you decide whether it is PCUs or vehicles? It is depending upon this P only. Okay, we'll just see one by one, don't worry. Now, so what is it, you can say, that W will be equal to which one? W will be equal to which one? Width of this rotary roadway, na? Width of this rotary roadway. How can you get that width of this rotary roadway? You can say that W will be equal to E plus 3.5, right? These are all the specifications whatever I am mentioning as per IRC only. Okay, now where what is the E, you can say E1 plus this E2 by 2, right? What is that E1 plus this E2 by 2? E1 is which width we have taken, if you remember? Entry width. E2 is which width we have taken? Exit width, right? So it is your which one, you can say, average of entry and this exit widths, right? Average of which one, you can say, entry and this exit widths will be taken as your E, you can say, we just observe, right? Next, how can you get that, right? That E we know, W we know. Yes, correct, Praveen. E we know, W we know. Then what are all there? L and P, na? Yes or no? That L, right? What is that L, you can say? L is nothing but your what? Length of weaving section, na? L is nothing but your which one? This is the length of this weaving section. Or you can also write it as which one? It is a distance between what, you can say? Yes, it is a distance between which one? Tell me if you just observe. It is a distance between which one? Tell me. It is a distance between which one? Tell me if you just observe. It is a distance between adjacent channelizing islands, na? It is a distance between the adjacent channelizing islands, or you can also call it as this distance between which one, you can say, entry and exit of what? Entry and exit points of which one, you can say, that weaving, na? Entry and exit points of this weaving, you can say, we just right, isn't it? Isn't it? Right, is that clear now? right? Is that clear now? Right? Right. Now, clear? Noted, everyone? Noted, everyone? Once noted, tell me. I'll just try to move on to the next. Shall I? Right. So this is your third slide, you can say. But what is that? So here, if you just consider, right, what are the different kinds of these weavings you are having, right? So I'll just show that weaving 328. So there are, what is the meaning of this weaving? Tell me, if you just observe, that a weaving will be equal to entry. Okay, it is having which one? This is three operations together, that is called as your weaving, you can say. One is your entry, right? Once the vehicles are entering, they will be traveling along with the main traffic, right? Entry plus a traveling plus which one? This is a exit, you can say, if you just observe, right? Entry plus this traveling plus which one? This exit, you can say, if you just observe, right? Isn't it? Right. So what are the different kinds of these weavings you are having, if you just have any idea? So let us say this is your which one, you can say that main traffic, na? So here which one is taken as the main traffic? The traffic which is rotating around the rotary, na? So now this is your central. So the traffic which is rotating around the rotary is there, na? Moving around the rotary, that is taken as your main traffic, you can say, if you just observe, right? As na? So this is your main traffic, right? And if you just consider, right, so this is your which one? This is your rotary, and what is that? Vehicles are traveling around this or not? Vehicles are traveling around this, you can say, right? Now here they are, this is entry, na? Vehicles are entering on the left hand side or right hand side? Tell me, if you just observe. Vehicles are entering on this left hand side or right hand side? Tell me. Vehicles are entering on this left hand side, na? Yes or no? So this is left entry, you can say. And how they are leaving, if you just observe, they are entering and they are traveling with the main traffic, and they will be leaving it, na? So leaving also on which side? Tell me. Left side of this main traffic or right side of this main traffic? Tell me. Leaving also on the left side only, no? So left entry, left exit, right? So what is it, you can say? Left entry and this left exit only, no? Yes or no? Left entry and this left exit only, no? Entering on left side and leaving also on left side, right? Left entry and this left exit, right? Here if you just consider, right, next, what is another type of traffic? This is given with which is symbol, you can say. This is your A traffic. A is the symbol we are giving for this. Okay, next, what is another one? If you just observe, do you give guarantee that always it is entering on the left hand side of this main traffic, traveling with the main traffic, only leaving on the left hand side? It may be leaving on the right hand side also, no? Is or no? There is a possibility or not? Yes, there is a possibility, right? It is entering on which one, you can say? This is left hand side. So entry is your left hand side, traveling with the main traffic, and leaving on which side, you can say? If you just observe, leaving on the right hand side, no? Is or no? Left entry, right, and right exit, you can say, right? So this is given with this which is symbol, right? That is your B. Okay, the traffic which is entering on the left hand side of this rotary traffic and leaving from the right hand side of this rotary traffic, right? That is taken as which one? This B traffic, you can say, if you just have, right? Isn't it clear? Now always do you give guarantee that they will be entering on the left hand side only? Always do you give guarantee that they will be entering on the left hand side only? Always they will be entering on the left hand side only? Is it 100%? No, they can be entering on the right hand side of this main traffic also, na? They can be entering on the right hand side of this main traffic also, right? Suppose if they are entering on the right hand side of this main traffic, right, what happens, you can say? If you just observe, this is your which one? This right hand side they are entering. So entry point is the right hand side of this main traffic, na? And traveling along with the main traffic, and what is it, you can say they are leaving on the left hand side, na? Is that no? Right entry, left exit, right? So this is given, right? This is given with which symbol, you can say that is C, na? Is that no? This is given with which symbol, you can say C symbol, you can say. What is the C symbol? C is the symbol we are giving for this traffic type, right? Which traffic type, you can say entering on the right hand side of this main traffic, traveling along with the main traffic, and leaving on the left hand side of this main traffic, right? Now there is another possibility also. Now what is another possibility? Yes, Praveen, correct, right? So that traffic is entering on the right hand side of this main traffic, traveling along with the main traffic, and after traveling for some distance it is leaving the main traffic on the right hand side only, or you can say. So what is it, you can say that is your D, na? Yes or no? That traffic is called as which one? That traffic is called as which one? This is D traffic, na? Yes or no? That traffic is called as which one, you can say D traffic, na? Yes or no? That traffic is called with which name, you can say that D traffic, you can say, right? A, B, C, D, if you just observe, right? Isn't it? Now here, according to this definition of this weaving length, right? What is the weaving length? Tell me. Weaving length is the angle between which one? Entry and this exit traffics or not? Yes. Can we say it is the distance between this entry and these exit points? So can we say here? Can we say here? So this is your weaving length. If you just observe, this is your weaving length L. Can we say in every type of this weaving, right? This is your weaving length or not? So here this is your which one? This weaving length L, you can say, right? Starting point. These are all which one? This weaving length, you can say, if you just observe, right? Isn't it? This is all which one? This weaving length, you can say, if you just observe, right? Isn't it? Isn't it? Right? Right? Clear now according to the definition, all of you? Right? Now they are entering parallel to the main traffic, or they are entering with some angle? Tell me. They are entering with the main traffic, they are entering parallel to the main traffic, or they are entering with some inclination to the main traffic? Tell me. They are entering in an inclined manner. Now if you just observe, some angle they are maintaining, right? So what is that angle they are maintaining, you can say, if you just observe, yet this place when they are entering, they will be entering with some angle, right? What is this angle called as? That is your entry angle, na? Theta entry, na? Is that no? Theta entry or not? That is your theta entry, you can say, right? And now they are leaving with respect to the main traffic, they are maintaining some angle and they are leaving. What is that angle called as, right? That is your exit angle, na? That is your exit angle or not? Yes or no? That is your exit angle, you can say, right? So now tell me, which angle will be more comfortable if you just observe entry angle? See, lesser angle is more comfortable to enter, or higher angle is more comfortable to enter? Tell me. Which one is more comfortable to enter? Tell me. This is a traffic, okay? There is a traffic you are having, right? Main traffic you are having, if you just observe, right? Suppose if you are right, if you are entering, right, what is it, you can say, if you are entering with a larger angle like this, it is difficult, na? If you are entering with a very larger angle like this, it is very, very difficult. But if you are entering with a smaller angle into this main traffic, it is very, very easy, na? So no, if you are entering with a small angle, right? So isn't it? So this one, what is this, you can say, right? This is your main traffic and you are entering with a lesser angle almost parallel to this, it is more comfortable. But higher angle like this, entering will be easier, entering will be very, very difficult, if you just observe, right? Entering in that manner will be very, 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 very difficult, or not? Entering in that manner will be very, very difficult, you can say, right? So therefore which angle should be more lesser angle is comfortable? Yes, now is that clear? Lesser angle is comfortable, right? Lesser angle is comfortable means, and at the rotary rate, what is that we need to ensure? We need to ensure that congestion should not occur, right? Congestion should not occur means outflow should be more comfortable than inflow. Suppose 1000 vehicles are leaving and 1500 vehicles are entering. What happens? Tell me. Every hour, if you just observe, 1000 vehicles are only leaving, 1500 vehicles are coming into this, right? What happens? Tell me. What about the remaining 500 vehicles? What they will do? They will struck up inside the rotary and they will create congestion or traffic jam, na? Then what is that we need to do? Outflow should be more and inflow should be lesser, na? Yes or no? Which one is better? Tell me. Outflow should be more or inflow should be more? Which one should be more? Right? Is it clear? Which one should be higher to avoid the congestion? Tell me, all of you. Outflow should be higher or inflow should be higher? Everyone. Outflow should be more comfortable than this inflow, na? So outflow should be happening from which one? These exit points, na? So therefore, to avoid this congestion, right, what is it you can say if you just observe? To avoid this congestion, right, what is it we need to have? To avoid this congestion. So what is that congestion you can say if you just observe? Tell me, what is the congestion? To avoid this congestion, outflow should be, okay, outflow should be more than which one? Inflow. But in between the inflow and this outflow, there is one more thing, rotary flow, no? The traffic which is rotating around the rotary, if you just observe, isn't it? So that outflow should be more than which one? This rotary flow, okay, rotary rotation flow, na? That rotary rotation flow, it should be higher than which one? This inflow, na? Isn't it? It should be higher than this inflow or not, right? Isn't it? Now, so for that, what is that you can say to avoid this congestion? E2 should be greater than or equal to which one? This E1, and E2 should never be lesser than E1. E2 should be either equal to E1 or greater than E1. Both are okay. But if E2 is lesser than E1, right, what happens you can say? If E2 is lesser than E1, right, what happens you can see if you just observe? If E2 is lesser than E1, right, what is that problem? Tell me. If E2 is lesser than E1, whatever the traffic coming on to this, right, it will be struck up there, na? Yes or no? It will struck up there or not? It is good or it is bad, you can say. Then it will result in a good kind of this design, or it will result in a bad or poor design of this rotary, you can say. It will result in bad or this poor design of this rotary, na? Yes or no? So therefore it is better we should not have this E2 lesser than this E1, right? Isn't it? You have to be very, very careful, right? Yes, no? Now congestion, yes, not connection, congestion. Yes, correct, Praveen. Right. So next, what is that you can say? Angle also. Now coming to this angle also, exit traffic should be more comfortable means what is that? Exit traffic should be more comfortable. Already we know that lesser angle is comfortable either for entering or for leaving. Lesser angle is comfortable or higher angle is comfortable? Lesser angle is comfortable, na? So theta exit outflow should be more comfortable means theta exit should be greater than or equal to that theta entry, right? Yes, na? Theta exit should be greater than or equal to which one? This is theta entry, you can say if you just right, isn't it? Is it clear now? Is it clear now? This yeah, radius also, higher radius will be more comfortable or lesser radius will be more comfortable, you can say if you just observe. Higher radius will be more comfortable or lesser radius will be more comfortable? Higher radius will be which one? This is more comfortable, na? Lesser than or equal to a? No. See, Pavan, tell me, lesser angle is for comfortable for merging and this diverging operations, or higher angle is comfortable for this merging and this diverging operations? Tell me. Entry is nothing but you are merging with the main traffic only, no? Merging, after it is merging with the main traffic, traveling along with the main traffic, and after that it is exit means what is that you can say? Diverging from the main traffic, na? So no, it is diverging from the main traffic, na? Diverging from the main traffic, you can say, right? Isn't it? So lesser angle is comfortable. So which traffic should be more comfortable? Tell me. Outflow should be running comfortably or inflow should be running comfortably? Tell me. If you wanted to have the comparative design, which flow we should make more comfortable? Tell me, for avoiding the congestion. Outward flow or this exit flow we should make more comfortable, na? Is that no? Exit flow, if you are making more comfortable, means exit angle should be comfortable. Exit angle should be comfortable means already we know that less angle is comfortable for any merging or diverging operation. So outflow, that is the exit angle, should be lesser compared to that entry angle. Clear now, Pawan? Is it clear now, Pawan? Clear or not? Yes, no? Hello? No. Radius. Which radius is more comfortable? Tell me. Higher radius will be more comfortable, or sudden small radius is more comfortable? Tell me. Very large radius is more comfortable, na? Yes or no? Because whenever it is a very large radius, we'll get a feeling that we are traveling on which one? This road, you can say, right? So we are getting a feeling that we are traveling on almost a straight line, right? Suppose if you are taking very sharp car, sudden turning will be there, right? Which one is comfortable? Higher radius will be more comfortable, na? Yes or no? Higher radius will be more comfortable, you can say, if you just update, isn't it? So large radius is more comfortable means, right? Large radius is more comfortable means, right? What is it you can say? Radius at exit should be higher, or radius at entry should be higher? Radius at exit should be higher than radius at this entry should be higher than which one? Right? Radius at which one? This radius of this rotary should be greater than which one? This radius at this entry, na? Yes or no? Because in between this entry and this exit, right? What is it you are having? Rotary traffic you are having, na? Rotary you are having or not, right? Rotary you are having or not, right? Rotary you are having, if you just observe, you can say, right? So rotary will come in between this exit and this entry points or not? Yes. Radius of exit is greater than this radius of rotary. It is greater than which one? This radius of entry, right? Is it clear now, everyone? Up to this point, right? How these dimensions came, is it clear? Is not? Isn't it? Clear or not? Everyone clear? Noted? Once clear, note down, right? Once noted, tell me all of you if it is done. Right? So shall I move to the next? Shall I move to the next then? This is fourth slide, you can say, right? Which point you can say, if you just update, this is your 328th point now. Now 329th point, you can say, if you just update 329th point, if you just observe, right? Is now? Now here angles, right? Which angles we have to select, if you just observe? Which angles we have to select, if you just observe? Tell me. Which angles we have to select? Tell me. Smooth diverging. For smooth diverging angle should be. For smooth diverging angle should be. 1 second, Pavan, I could not. Small. Yes, yes, obviously. That is what we have mentioned now. As no. Exit angle means diverging angle only, no? Exit, diverging, both are same or not? Oh, sorry, I have written reverse. Sorry, I have written reverse. I said lesser, but I have written higher. Yeah, that is what you are saying, Pavan. Is it so? Yes, yes. So that is lesser actually. That is lesser. Yes, yes. That is what you are saying, Pavan. Is it so? Now, this exit angle should be lesser than or equal to that entry angle. While I was saying, I said exit angle should be lesser than or equal to entry angle only. But okay, I have written in a reverse manner. Okay, let it be. No problem. Right. Lesser angle. Now happy? Satisfied? Okay. Right. Okay. Done? Now. So here if you just observe, right? Do you provide any super elevation? Do you provide any super elevation? You can see if you just observe this rotary. Because it is a horizontal curve. Fully happy? Very good. So this is your horizontal curve you are having. Na? Do you provide anything you can say? Do you provide any which one you can say? Do you provide any super elevation, or we don't provide any super elevation? Tell me. We don't provide any super elevation. Na? Suppose if you provide super elevation one side, right? Let us say between legs 1 and 2, if you are providing super elevation like this, vehicle will come like this and it has to jump onto this. Na? So it is better you have to provide it the straight horizontal level condition only. Don't provide super elevation, right? It's not. So now what is that you can say, super elevation we should never provide at that place if we just have right, isn't it? So then vehicles are supposed to jump from this leg 1 to which one, this leg 2, right? Is it practically possible? No, no. Only in our Hollywood movies, Tollywood, Bollywood movies and Balai Babu movies it is these kind of things are possible, right? Yes, no? Isn't it? Yeah, it will become F1 racing, right? Yes, absolutely, right? Isn't it? Next, what is it you can say? This is here radius at exit. How much we have to take this radius at this exit? It is taken as which one? This is 2 to 3 times which one? Radius at entry. Na? 2 to 3 times this radius at this entry you can say. Now, what is that radius of this rotary if you just observe? Radius of this rotary or this radius of this central island, how much we have to take? Tell me. It should be more than the radius of this entry only, but it should be lesser than the radius of which one, this exit. Na? How much? What is it? Tell me if you just observe. What does it tell me? Radius of rotary will be equal to radius of this central island, right? What is it you can say? Tell me. How much? Anyone having idea? It should be lesser than that of exit radius and more than that of entry radius, right? How much? Somebody? No, not 1.5. Guess. You are nearby, but it is not exactly. Okay? You are not nearby. It is not exactly. Nearby that 1.5 only, but that is not. Okay? How much it will be? That is 1.33 times that radius at this entry. Okay? Okay? If you know the radius at entry, then you can get the radius at exit, radius of rotary. Na? So how can you get the radius at the entry? You can say right. What is that radius at this entry? You can get it. Yeah, yes. 4 by 3 means 1.33 only. No. Radius at entry. How can you get that? Tell me. So if you just observe that E plus F will be equal to, right, what is it you can say? That is your V square by this GR. Or capital V square by which one? This 127 R. Now tell me here, do you provide any super elevation or we should not provide any super elevation? You can say we should not provide any super elevation. Is it no? We have written radius at exit equal to 1.52 this 2 times this. Yes, right, 2 to 3 times this radius at entry. You can also take it as which one? This 1.52 to 2 times this radius at this entry. Yes, you can take like that also, no problem. Yes, you can take like that also, but generally we can provide this one also, no problem, right? Yeah, this only you can take, right? 1.52 this 2 times radius at entry. This is the most commonly used, you can say, right? What is this? This is the most commonly used one. Okay, and nowadays this is also used. Okay, because these are the specifications will be changing from time to time, right? So you need not worry about this. Okay, only thing is this we have to remember, radius of this exit is higher than the radius of rotary, it is greater than the radius of entry. That is very important to be noted. Okay, but okay, these are not that much important to be worried about. Okay, now radius at entry will be what? What is that radius at entry? How can you get that? This is your radius at entry. Na? Radius at entry will be equal to, that is your small v square by which one? This is g into that f. What is the f? Coefficient of this lateral friction or coefficient of this angular friction? Whichever one it is, tell me. Or capital V square by which one? You can say that is your 127 into that f. Na? So coefficient of this longitudinal friction or it is a lateral friction, everyone. Whenever there is a curve means, right, what is it you can say? Lateral or longitudinal friction, which one will come into picture? If you just observe, all of you. Which one will come into picture? Tell me. What is it? This is your coefficient of lateral friction only, obviously, na? Yes, absolutely, it is your lateral friction. And why? Whenever it is a curve means, whenever a vehicle is moving in a curved path means, centrifugal force will come into picture. Na? Centrifugal force will pull out the vehicle in the outward direction, right? So to avoid that, this friction in the inward direction we should have, right? Isn't it? that super elevation also will turn the vehicle inwards to avoid this outward overturning of this vehicle, right? So coefficient of this lateral friction, right? How much we have to provide? Tell me if you just observe. What is the coefficient of lateral friction we have to provide? Tell me if you just observe. Coefficient of lateral friction, how much it will be? That is your 0.432. Which one? This is 0.47. Very large value we are providing. Why? If you observe, around this roundabout or this rotary will be having very rough surface compared to the approaching roads. Did you observe that any time at this junction, road junction, that a rotary place? Did you observe that? Why? Because to safeguard, because the radius will be very छोटा बच्चा radius ना, so इस छोटा बच्चा radius में centrifugal force ज़्यादा हो जाएगा ना, ऐसा ना? Capital P equal to mv square by this r, right? Radius denominator value small है तो क्या होगा? Total value will be very larger, right? When the total value of centrifugal force is very larger, what happens? Vehicle will be subjected to accident very easily na. So that is why friction, super elevation is also not there. Then entire centrifugal force effect will be taken care by friction only na. Now we are going for that, right? Yes na? No, you don't observe friction, Praveen. You don't observe friction. Just you observe a roughness. You are having this approach road na, roughness you just observe, not the friction. I am not asking you to go and measure the friction, okay? Here this approach road will be there na, just at some distance you observe how smooth it is, and you observe around this rotary how rough it is, okay? That you can do, Praveen. Understood what I mean? Surface roughness, right? Understood what is the meaning of what I said, okay? That you observe. Don't measure the friction. It is impossible to measure the friction when vehicles are moving, right? F is this one, right? Now what is the design speed? You can say if you just observe. What is the design speed if you just observe? The design speed capital V will be equal to which one? That 30 kmph for what? Urban areas, right? And 40 kilometers per hour, which one? 40 kmph for which one? This is rural areas, right? So we will be stopping with this, right? So next class will be on which date? Tell me. So already all classes are scheduled. Next class on which one? Tell me. Next class on 4th na? 4, okay? 4, 8, 24, right? So 4th, or it is not on 4th actually. It is on which one? Monday. Again Monday will be which date? Tell me. Monday will be which date, all of you? Every Monday, Tuesday, Wednesday will be having the classes, right? Monday, Wednesday, and which one? Today is Friday na? Every Monday, Wednesday and this Friday, these YouTube live classes will be having, okay? 5th, is it 5th? Okay, whatever it is. Right? Is it clear now? Clear now everyone? Whatever we have discussed up to this? Is it clear everyone? Right? Shall I close the session? I'll be closing the session. Thank you all of you. Have a good day. Yeah, it's already scheduled, right? All classes almost are scheduled, right? Every Monday, Wednesday and this Friday will be having the classes, right? 3 classes, okay? I'll be closing the session. Thank you all of you. Have a good day. Thank you. So tomorrow we'll be having the special class, that free class only in the Unacademy app we'll be having, right? YouTube classes will be which one? YouTube classes will be which one? You can say that YouTube classes will be on Monday, Wednesday and this Friday, and another special classes that those are also free classes only. They will be on the Unacademy app. Tuesday, Thursday, Saturday will be there. Okay. Thank you. Thank you.